right, we're going to start talking about sequences today. Now, we talked about sequences last year, okay? So we're going to kind of build right on top of that. Okay, first of all, what is a sequence? Sequence is a list of numbers in a certain order, okay? Patterns. We've talked about patterns since we probably started kindergarten. We did simple patterns with colors, shapes, okay? Now we've kind of moved up to sequences, which we have a certain way to do a pattern, okay? But it's just a list of numbers in a certain order. And then we have the word term, okay? Term we talked about in our equations. Terms were everything that made up the equation. Here, a term in our sequences is all the numbers that make up that sequence. Okay? So it's one of the numbers in the sequence. The girls' bathroom is. Okay, now the first sequence we're going to talk about is an arithmetic sequence. An arithmetic sequence is a sequence in which each term is found by adding the same number to the previous term. So that number has to be the same number that you see between each term. Okay, if it changes, it's not an arithmetic sequence, okay? Even though it might be adding, it has to be the same number. Now, if some of you had me last year, we talked about that you could add or subtract. Last year, we really didn't get into a whole lot with integers, meaning adding and subtracting integers. So this year, everything has to be in relationships to adding. Okay, so if you have a subtracting, we've got to make it into an adding problem. And here's our example at the bottom. My sequence would be 4, 8, 12, 16, and 20. So what we noticed between 4 and 8 was we're increasing by 4. Between 8 and 12, we're increasing by 4. So each term, we're increasing by the same number. That is what makes it an arithmetic sequence. Okay? All right. Now, it says, what is a common difference? Common difference is the difference between each number, or, in other words, it's what you are adding each time. Okay? So it's the difference between each term in your sequence. And so we had a minute ago, that was the one we had in the previous problem. Our common difference was 4 because we were adding 4 every time. Some of them right slow. Oh, never mind. Here's the tip. Alright, arithmetic sequence. Now, y'all don't have to copy this one, but we're going to kind of go over it. Kind of a review. We're adding an arithmetic sequence, okay? And it's called a common difference when you're doing the same thing every time. So let's look at this one. 2, 4, 6, and 8. What am I doing between each term? I'm adding 2. So the common difference is 2. Okay? 50, 40, 30, 20. Jacob? Okay, now I can't write it as a subtract 10. So how do I change that from a subtract 10 into an add? Positive what? Now, when I change integers, if I change that subtract to a plus, what happens to that positive 10? it becomes a negative 10. So my common difference here is I'm adding negative 10. Does everybody see that? So we can't talk in terms of subtracting when we're talking about sequence. You have to change it to an add. Okay? They have a question with what I did there to get the negative 10. Okay. Okay, here's another one. So 4, 7, 10, 13. Who can tell me the common difference? Chase. It's a 3 because I'm adding 3, so it's just 3. 27, 24, 21, 18. Benji. Now, I can't minus, so I have to do what? Add negative 3. Okay, so I'm doing an add a negative 3. What about 5, 20, 35, 50? Oh, somebody different. Paul. I'm adding 15. So my common difference is 15. Did everybody see that? Arithmetic is pretty simple just because we're adding and we like to add better than anything. Okay, now you do not have to copy this one either. Arithmetic sequences, if we were to graph it, okay, it would look like a line, which is called a linear pattern. If you pay attention, linear is spelled with line, the first 4, so it's got to make a straight line. Okay, so those, when they're graphed, will make linear. Okay, next sequence we're going to talk about is a geometric sequence. Geometric. Geometric sequence is a sequence in which each term can be found by multiplying the previous term by the same number. So geometric is multiplying. I added a page real quick. Now, go really quickly, okay? If I am dividing by 2/3 and I've got to change it to multiply, what am I going to do? What am I going to do, Shelby? Okay, so I'm going to multiply by the reciprocal, which is 3/2. What if I was dividing 1/4? What would that become, Colton? 4/1. Now, could you also change 4/1 to just timesing by 4? Okay. What if I'm dividing by 12? What's the reciprocal of 12? Somebody different, Chase? Timesing by 1/12. So remember, I have to make that a fraction first and then flip it, okay? So at any point when we're doing geometric sequence, I don't want dividing. I want you to change it to multiplying. Okay? Right, you're never subtracting or dividing. It's always in terms of adding or multiplying. Now it says, what is a common ratio? The common ratio, okay, is the ratio between each number in the sequence, or what you're multiplying by. Okay? Now they use the word ratio because sometimes it does look like a fraction. Okay, so that's where the common ratio comes in. And then here was our pattern, our example. We had 2, 8, 32, 128, 512. If you notice the difference between my geometric sequences that increase and my arithmetic, arithmetic does not increase to big numbers very quickly, but geometric does. If you notice, we jumped from 8 to 32, and then all of a sudden we're into hundreds, and then 500s, okay? And the next ones we're going to be over into the thousands, okay? So you got to be careful to understand that geometric is going to increase quickly. All right. So again, geometric, you don't have to write this one. We're going through some examples. We're multiplying by the same number, and that's called a common ratio. 1, 4, 16, 64. What am I multiplying by to get to the next number, Jacob? I'm multiplying by 4. So my common ratio is 4. 400, 200, 150.
Oh, yeah, 50.
Am I multiplying by 50? Because 400 times 50 is not going to give me 200. Shelby? Okay, I'm not dividing by 2, so I've got to rewrite it. I'm multiplying by 1/2. So Shelby says, okay, I'm dividing by 2, but remember we can't divide, so we've got to change that to a multiply by the reciprocal, so that means I'm multiplying by 1/2. Okay? Now, they give us a decimal form. I don't like the decimal form. Okay, keep it as a fraction. Okay? 4, 8, 16, 32, 64, 128. Jace? Multiplying by 2. 2,000, 1,500, 250, 125. 62.5, which I don't like, but that's okay. Paul? Now, dividing or multiplying by 1/2. 6, 24, 96, 384. What's something different? 1. What do you think that one's going to be? Do it now. Times 6. 6 times 6 is 36, so that's not 6. 6 times what gives me 24? Now, if you have trouble, here's one thing you can do. You can take the second term and divide it by the first term. So if you take 24 and divide it by 6, that tells me that 6 times the number in your calculator would give me the next number. So 6 times what? 4. Now check it. 24 times 4, does it give me 96? Okay, 96 times 4. Does it give me 384? So my common ratio here is going to be timesing by 4. Okay? Alright, now, again, you don't have to graph this one. The exponential pattern is what when we graph a geometric sequence. Remember when I said that number increases very quickly? Okay? Look how that it goes from a straight line, okay, into a curved line. Okay? And it's increasing very quickly. Alright. Now, we're going to make our own patterns really quickly. Alright? If they told me my first term was 1, you might write 1 or 2 down, but we're going to kind of do them together, okay? And my pattern was n plus 2. N is a term. Doesn't matter if it's my first term or my 30th term. I'm going to take that term and add 2 to get to the next one. So I want to jump forward a page just so I can work on this. So my first term was 1, and it told me I'm adding 2. So what's the next number, Colton? Okay, and then the next number, and now the next number. So every time in this pattern, I'm adding 2. Okay, does everybody see what I did? Okay, let's talk about a geometric pattern. Geometric means I'm multiplying. My first term is 1, and my pattern is 2 times n. So on this one, I'm going to start with 1, and I'm timesing by 2. So what's the second term, Dakota? 1 times 2 is 1 times 2. 2. What's 2 times 2? 4. 4 times 2. 8 times 2. And then my pattern will continue going forever how many terms I need it to put on there, okay? You may have a question on that. Alright, let's do this next one. Arithmetic. My first term is 1,000, and my pattern is n plus negative 50. So we start with 1,000, and I'm adding negative 50. So who can tell me what the next term is? Chase? Who can tell me the next term? Jacob? Who can tell me the next term? Benji? And Shelby? Okay. All right, and it would continue going over how many terms I wanted. If I said list me the first 15, then we've got 5 right there. I would have to give me 10 more, okay? Anybody have a question on the arithmetic? Okay, let's do a geometric again. First term is 1,000. Again, I don't like this 0.5. This really means 1/2 times n. Okay? So if I start with 1,000, okay, and I multiply that by 1/2, what's my next number going to be? It really means I'm dividing by 2. Chase?
500.
Okay. What's the next one? 500 times 1/2, Paul? 250 times 1/2. Benji? 125. Now, can 125 multiply by 1/2 and get an even number? No. So what I would do is I would keep it a fraction. So 125 times 1/2 would be 125 over 2, and I would leave it. Okay? If I did the next one, then I'm going to take this and multiply by 1/2, which tells me then I'm going to take 125 and multiply it by 1, and 2 times 2, which would give me 4. And I would just keep going. Okay? But I would keep it that fraction. Anybody have a question with that? All right. All right. Consecutive terms. When I talk about consecutive terms, that means the number that are beside each other in a sequence or the pattern. Okay? If I was talking about you guys sitting in consecutive seats, Colton and Mason are consecutive seats. Shelby and Colton are not. Okay? Consecutive means they're one right after the next. Okay? Now, a variable expression can show the rule of a pattern. And that's what we just did on that previous problem when they said n plus 2. That was our rule. 2 times n, that was our rule. Okay? So variable expression means that we're going to put, okay, a variable in it with our expression that's going to help us make our sequence. Okay? So it's the rule to making our pattern. Now, when do we use a variable expression? We use a variable expression can express the relationship between 2 consecutive terms. Okay? We're going to use it to express the relationship between 2 consecutive terms. Alright, so I want you to tell me if the following is arithmetic or geometric. Then you're going to tell me if it's a common difference or common ratio, and then you're going to tell me what it is, okay? So, 10, 15, 20, 25, 30.
Arithmetic.
It's arithmetic sequence. So is it a common difference or common ratio? Common difference. And what is the common difference? What am I doing between each term?
You're adding -5.
I'm adding -5.
But you're subtracting -5. But you're adding 5.
I'm adding 5. So my common difference here is 5. Okay? Alright. 2, 12, 72, 432, 2,592. Chase.
It's geometric.
It's a geometric sequence.
Common ratio.
It's a common ratio.
Common ratio is
And common ratio is 6. You don't have to say the times, because when you told me common ratio, I should automatically commit that it's a multiply, and I'm going to do that by 6, okay? What is the next term in this sequence? So 5, 20, 40, 80, 320, 1,280. What's the next term again? 5, -1, -7, -13. Jacob? Oh. Benji? -19. Because the common difference was I was adding -6 each time. So negative 13 plus negative 6 would have given me negative 19. Okay? What's the next term? Negative 3, 6, negative 12, 24. Nope. Paul? Negative 48. Now, pay attention here. When you get a pattern like this, it's a negative, a positive, a negative, a positive. Okay? You're going to probably be multiplying by a negative number. Okay? So that'll be a good indicator there to know what you're multiplying by. Okay? Okay, what's the next term in the sequence? Negative 400, negative 380, negative 360, negative 340, Shelby? Negative 320. Okay? Oh, that's the one we just did, sorry. Thank you. Next term in the sequence, 100, 75, 50, 25, 0. What's the next one then? Negative 25. Okay? Good job. Next term in the sequence, 12, negative 48, 192, negative 768.
Negative 11.
Would it be negative?
No, it'd be positive.
Positive. Okay? And positive what? Multiply it again to make sure. Multiply yours again. I think you probably had another number on your calculator.
Yeah,
Okay. All right. Any question on that? Oh,